So now we are going to study vehicle on banked road, as mentioned on the title on the board, vehicle on banked road. In the last two videos, we have studied, last three videos in fact, we have studied the same chapter, rotational dynamics. We are continuing with rotational dynamics. So in that we have seen, in the first video we have seen the basics of circular motion. Then in the second we have seen some kinematics and numeric based on the kinematics of circular motion. And in the third video we have studied vehicle or by a car on unbanked or level surface road, okay, curved road, unbanked curved road means in that both the levels of the road, okay, both the levels of the road were on the same level. And after that we have seen a bike or a vehicle in well of death, okay, a bike is revolving in a well of death. So what should be the minimum speed with which he can safely drive along the wall of the container or wall of that cylinder? And after that we have seen some numeric based on those topic, whatever we have studied in third video. Okay, so those who have not yet watched all the three videos, there is a link in the comment section, okay, in the description of this video. You can copy that link and you can watch the previous videos of the same chapter, that is rotational dynamics. This is the part of rotational dynamics, but we are studying in that rotational dynamics we are studying circular motion. Okay, now vehicle on banked road, this is also part of circular motion. Now first of all, we'll see what is meant by banked road. Okay, particularly on ghats or on a curve, when a vehicle is taking a turn on a curve road, on that curve road the inner edge of the road is at a ground level, at a horizontal level, and the outer edge is raised up. So the two levels are not at the same level, two edges of the road are not at the same level. But in the unbanked road, both the levels, both the edges are on the same level. But on banked road, the inner edge of the road, if I am taking this turn, so the inner edge is at the lower level and the high outer edge is raised upward. Okay, so the road becomes tilted with the horizontal, okay, like this is the horizontal and this is the surface of road. So this surface of road is tilted. So the angle, such tilting of the road is called banking of road. Okay, and the angle theta to which it is tilted is called as angle of banking. Okay, now here this vehicle is moving along this curved road. So I have taken the cross section of vehicle and the road. So this is the cross section of vehicle and the road. Let this point I'll give it a name, say C, is center of mass of the vehicle. So this vehicle is acting as the point. So at this point, so on this vehicle, on the surface of the road, two forces are acting. The vehicle, two forces are acting on the vehicle. Okay, so what are those two forces? The first is mass, its weight, which is acting downward, and the second is normal reaction. This normal reaction by the surface of road and which is perpendicular to the surface, that is n. So n is the normal reaction and mg is its weight. So weight is acting vertically downward and normal reaction n is acting perpendicular to the surface of road. Okay, so I'll write here the two forces acting on vehicle are, first one is its weight, mg, and second is normal reaction, capital N. Okay, is it clear up to here? Now this, since the normal reaction is perpendicular to the road. So we will resolve it into its vertical component and horizontal component. So the vertical component is n cos theta and the horizontal component is n sin theta. So this component n cos theta is balanced by mg, that is weight of the vehicle, whereas the horizontal component n sin theta is balanced by centripetal force. Okay, balanced by centripetal force. We have seen what is meant by centripetal force and centrifugal force. Okay, so what is centripetal force? If m is already mentioned, mass of vehicle, r is radius of curved road, okay. Theta is angle of banking, v is speed of vehicle, okay. So therefore the this centripetal force, okay, is balanced by n sin theta. So n sin theta equals to m v square upon r, and n cos theta is m into g. So let us name this as 1 and this as 2. Is it clear up to here? I'll repeat. The two forces acting on the vehicle is its mass, that is acting vertically downward, that is mg, and the normal reaction, which is by the surface of road, it is acting perpendicular to the surface of road, and that is m. Okay, so this n is resolved into n cos theta and n sin theta. N cos theta is balanced by weight mg, and n sin theta is balanced by centripetal force mv square upon r. Okay, now let us divide 1 by 2. We'll continue here. Divide 1 by 2. So it will become n sin theta upon n cos theta equals to m v square upon r whole upon n into g. So n will get cancelled. This will become tan theta. Okay. So tan theta equals to, again this m will get cancelled. It will be v square upon r g, or theta equals to tan inverse v square upon r g, or if you want to write in terms of v, so v is equal to under root r g tan theta, where g is acceleration due to gravity. Okay, so these are the two expressions which we have derived, this one and this one. Now if we have theta is known, if theta is known for a particular road, theta is fixed, r radius, that is also constant, and g, that is also constant, acceleration due to gravity. If you know all these three quantities r, g and theta, we can determine v. Okay, what is the velocity of that velocity of speed of that speed of vehicle on that particular curved road, we can determine. Okay, where, or if you want, if you have v, particularly in racing track. Okay, so they decided that the vehicle should cross with maximum so and so maximum speed, say 150 kilometers per hour. It should cross this curved road with a maximum speed of say 150 kilometers per hour. So in that case, v is known. What the radius should be kept of that particular track, that is also known. So by using this, they can determine, we can determine the theta, value of theta. How much should the road be tilted? Okay, so that theta can be decided from this equation, this expression. And if all these quantities are given, and if you want to determine v, so that can be velocity, that is speed of the vehicle, so that can be determined by this expression. So if you remember the previous two expression, that is for the unbanked curve road and also in the wall of death, and now in banking of road, if you see, compare those speed of the first two case and this third case, you will find that this is independent of mass. There is no mass. So irrespective of the mass of the vehicle, whether it is a say Maruti 800 Alto or it may be a truck of 16 wheel, so this expression will be same for all the vehicle irrespective of their mass. Okay, now this is the thing what we have studied today, that is vehicle on banked road. If you want to copy, I am moving aside. You can take screenshot and you can then make the notes of this. Okay, so here I'll write for your knowledge that this is centripetal force. I'll write with different color so that it will be easy for you to understand. Centripetal force. Okay, this expression is for centripetal force that you can note in your further notebook. Okay, now in the next video we'll see. Here we haven't considered the friction. We haven't considered the friction between the tire and the surface of road, and we have derived this expression. In the next video, we'll consider the friction also. What if friction is there? Friction is always there. Okay, friction cannot be removed from the surface of the road. So, if we consider the friction, what will be these expressions? This we'll see in the next video. Okay, so I request you again to subscribe to our channel and also like to the video, and if you have any numeric problems based on this, in the next video I am going to take numeric problem based on this topic. And further, if you have anything difficulties, you can ask me in the comment section. Okay, and for the previous two videos, you can see, previous three videos you can see in the description. The link is mentioned in the description. There you can watch those previous videos. Okay, so thank you for watching, and again I request you to subscribe to our channel, and also you can ask me the question in the comment section. Thank you very much.